A molecular equation shows the complete neutral formulas for all the compounds in the reaction, and that's what we've been writing so far. We look at the complete formulas. A complete ionic equation gives us a better idea of what's actually occurring, because in this equation we show any aqueous ionic compounds as ions. Because if potassium nitrate is dissolved in water, is the potassium ion with the nitrate ion? No. They're in the same beaker, they're at the same party, but they're kind of moving around, right? So let's indicate in the equation that they are separate. They're in the same party, they're at the same party, but they're not together, right? So to write the complete ionic equation, you first have to have a molecular equation. And then anything that's aqueous, you separate into ions. Aqueous ionic compounds get separated into the ions. If you see anything that's a solid, a liquid, or a gas, don't mess with those, just copy them down as they are, because they are not forming ions. In the complete ionic equation, what we will notice is that there may be some spectator ions. Those are ions that are not changed. So, these two couples went to the party, and the one guy and the one girl hit it off. What happened to the other guy and the other girl? They're just hanging out watching, right? They didn't get changed. We call those spectators. They're just watching. So to simplify what's going on in the equation, we can take the spectators out and just look at the actual reaction that occurred between the ions involved. That's the net ionic reaction. Just like your net paycheck, they take out taxes and all that other stuff, right? That's what you actually get to take home. The net ionic equation, we've taken out the spectators, the stuff that's not actually participating in the reaction. They were just there. And it's just the bottom line. When we talk about a species, we use the word a little differently perhaps than biologists do. In chemistry, a species just means a kind or sort of thing. So all the different molecules and ions. We get tired of saying all the different molecules and ions, molecules and ions, molecules and ions. Species covers all of those. So this is a summary molecular equation, shows the complete neutral formulas for every compound in the reaction. You're not going to see any charges in a molecular equation. The complete ionic equation shows all the species as they actually are present in solution. The net ionic equation shows only the species that actually participate in the reaction. Let's do some. Consider this reaction occurring in aqueous solution. Write a complete ionic equation and a net ionic equation for the reaction. So we already have the molecular equation. To write the complete ionic equation, we want to find anything that has AQ. And if it's aqueous, we're going to separate these things into ions. So when I see 2 HBr aqueous, I've got 2 HBr's, and those are going to separate into ions. I'm going to have a hydrogen ion that's aqueous, and a bromide ion that's aqueous. They're dissolved in water. If I started with 2 HBr's, how many H's do I have? 2. And how many Br's? 2. So I had two of these couples, right? And so I've got 2 of the guys and 2 of the girls. And then this one's also aqueous. So here's calcium hydroxide. This is 1 calcium ion with 2 hydroxide ions. So I've got a calcium ion and 2 hydroxide ions. This equation is balanced. I find it easier to just keep track of things and write down the same number of them as I'm writing the complete ionic equation. If that's really confusing for you, you can just write the ions down, and after you get all the ions taken care of, you can go back and balance it, but I think that's more work. Any questions so far? Over here, this is a liquid. Don't do anything to it, just copy it down. Liquid, solid, gas, leave it alone. Only AQ gets separated into ions. So I've got 2 H2O liquid, I'm just going to write 2 H2O liquid, and I don't have to mess with it. The next one, though, is aqueous, and so I need to separate this into ions. So there's a calcium ion, and the other part is a bromide ion. It's not a Br2 ion, it's 2 bromide ions. Okay? So there's calcium, and there's 2 bromide ions. In nomenclature, we never talked about a Br2 2- ion. We never did anything like that. That's one of the weird things that students sometimes do here. They'll just take this off and call it Br2 2-. No, it's just 2 bromides. Okay? Okay, so that's the complete ionic equation. Anything that's aqueous, we separate it into ions. You can check it, it's balanced. The net ionic equation is we're going to look for spectators. People that came to the party and they just didn't get interacting with anybody. So do you see any ions that are the same on the left side and the right side? Yeah, what are they? Yeah, bromine. So here I've got 2 Br, and here I've got 2 Br. She didn't get involved with anybody. And the other one's calcium. There's calcium, and there's calcium. Did they participate in hydrogen and hydroxide hooking up? No. Hydrogen and hydroxide would have hooked up whether bromide and calcium were there or not. They just happened to be there. So the net ionic equation just shows what actually happened in the chemical reaction. So let's copy down what's left then after we cross off the spectators. I get 2H plus aqueous plus 2 OH minus aqueous. And that's making 2 H2O liquid. Now what's weird about that equation? Everything has a coefficient of 2 in front of it. You see that? Do we need all those 2's? No, we don't. This is not something I would try to trick you with on an exam where I would give you this equation and then I'd give you one without the 2's and expect you to pick the one without the 2's. But we don't need those 2's. So that's the net ionic equation. Bottom line of what's happening in this reaction is that hydrogen ions and hydroxide ions are getting together and forming water molecules. Calcium and the bromide had nothing to do with it. Any questions? Yes? You should always write the state symbols when you're doing these sorts of equations.
Would it be wrong if those 2's were left there?
Pardon me?
Would it be wrong if those 2's were left there?
It wouldn't. I wouldn't mark it wrong if you left the 2's. I'm not sure what mastering chemistry might do. Not sure what he would do.